We have a basketball player jumping straight up from the ground. Basketball player jumps straight up, comes straight back down. One of the things we can capitalize on this and that we know about is that we know that acceleration caused by gravity is 10 meters per second squared. And we also know there is symmetry. The symmetry means that this time equals this time. The time up equals the time down. And the velocity, the initial velocity, is going to equal the impact velocity. So there's some symmetries going on here. So they jump straight up to grab a rebound, and they're in the air for 0.8 seconds. Doesn't seem like a long time. How high did she jump? Well, let's kind of put these in perspective. 1 meter is about 3 feet. So 3 meters is about 10 feet. 10 feet doesn't really seem like a reasonable height for anyone, given that that's higher, that's the height of the net on the basketball court. So someone is not going to jump so high that their feet are above that. 1.2 meters is going to be about 1.2 times 3 is about 3.6 feet. So we're talking 3.5 feet. It seems awfully large, but there might be someone who could do that. And we talk about someone having a 36-inch vertical. That's very high, and this is more than that. This is more like 43 to 44 inches vertical leap. So that is, if they're goofing around in this question, it might be possible. Let's take a look at 0.78. So 0.78 seems very specific. And if we take 0.8 times 3, that is going to be about 2.4 feet. A little bit less than 2.5 feet, so a little bit less than 30 inches. So that's pretty high. But that is somewhat reasonable and certainly more believable than 3.6 feet. And this 0.5 meters is going to be about 1.5 feet, which is about 18 inches. And that may not seem like it's very high either. So probably this one's out, it's unreasonable. And the first one's out, it's unreasonable because it seems too low and too high. But we can actually calculate this distance. So what we have is time, and we're looking for distance. So we have two equations we could use, v equals at plus v0, and z equals 1/2 at squared plus v0t plus z0. Now, we're looking for a height when we know the time, and we know the acceleration caused by gravity. We know the acceleration, we know the time, but we don't know either the velocities. And it's not going to get us to the position, so that's why we use this equation. So we want to know the height. So we have 1/2 of 10, and this is 4/5. 0.8 is 4/5. The initial velocity, we don't know the initial velocity, and we don't know the z0. But here's what's interesting. In this problem, we know we go from some velocity v0 to a velocity equal to 0 at the top. And then at equal heights on the way up and down, those velocities are equal to each other. So now if this situation were different and we said that the student, the athlete, started up here and just dropped down, that is going to be exactly the same as if they had jumped up. So we can just look at the second half of this motion and say that the initial velocity is 0. So that term drops out, and if we make that initial height 0, we would now be calculating, acceleration is -10 by the way, we would now be calculating how far it fell. Now if she's in the air for 0.8 seconds, that means this is 0.4 on the way up and 0.4 on the way down. So working through here, we have -5 times 4 squared over 5 squared. And there's supposed to be a, let me just change that. So the time isn't 4/5, it's 2/5. excuse me, because half of 0.8 is 0.4, and 2/5 squared is 4 over 5 squared. So this squared goes away, this 5 goes away, and we are left with negative 4/5, which is negative 0.8. Negative 0.8 is how far they went this way, so minus 0.8. So the maximum height up would be positive 0.8. And the closest answer to that is 0.78. So a really fun question.